Today we're going to learn how to add like terms. The first thing we're going to do is we're going to learn some vocabulary. So a term is where you have a number, a variable, or a number and a variable multiplied or divided together. So I'm going to type that in here. So that's a number, a variable, or a number and variable multiplied or divided. Now, what that can look like is the following. We could have just a number, for example, 6. It's also referred to as a constant. We could have a variable like y. We could have a number and variable like 5x being multiplied together. Basically, any combination of number and variable being multiplied or divided is considered a term. So if I have x to the second power, for example, that is the same thing as x times x, so that is also considered a term. Okay, so like terms would be terms that have the same variable or constants, and constants or numbers can also be like terms. So let's look at some examples. Here we have 2y and 4y. Those are like terms because they both have y's in them. 5x squared and negative 10x squared are both like terms because they both have x squares in them. And then our last example here is going to be 3 and negative 11. Those are both constants or just numbers all by themselves without any variables. So that's what a constant is, a number by itself without variables. And all constants will be considered like terms. What would not be considered a like term, for example, would be 4x squared and 2x. These are not like terms. And the reason why is because one of them has an x squared and one of them just has an x. They have to have the same variable with the same exponent in order to be considered like terms. So if we look up here at this algebraic expression, we have 3 x's and we have 4 y's, and we're going to change this to addition, and so we have a negative 7. And so therefore, we don't have any like terms because there's no other x's to go with our 3x, there's no other y's to go with our 4y, and there's no other constant or number to go with our negative 7. So the next thing we're going to talk about are coefficients. Coefficients are numbers multiplied or divided with variables. For example, 2 and 2x is considered a coefficient. Negative 4 and negative 4m is considered a coefficient because it's a number multiplied by a variable, and 5 and 5x squared is considered a coefficient. You could also see examples like x divided by 3, y squared divided by 4. So in these cases, the 3 and the 4 would be coefficients. So if we look up in this example, what numbers do you think would be our coefficients? If you think 3 and 4, you are correct. Negative 7 is not a coefficient because there's no variable. So a constant is a number that's not with a variable. It's the number all by itself. So if you look up in 3x plus 4y plus negative 7 is going to be your constant. So this number here is the constant. And the coefficients are 3 and 4. You can think of it this way. A constant, if you think about it, it means always staying the same. Well, a number always stays the same. Negative 7 is always negative 7. It doesn't change. Whereas a variable is a letter that represents an unknown number. So a variable can vary. We don't know what it is. It can vary. It could be all kinds of numbers. We don't know. Now, when you have two variables, that means it's going to represent two different numbers. So up here where we have 3x plus 4y, the x and the y are unknown numbers, but they're not the same number. So now we get to simplifying algebraic expressions. So this is an algebraic expression. It's just a bunch of terms that are added together. That's an algebraic expression. You can tell it's not an equation because there's no equals. So if there's no equals, it's an expression and it's considered algebraic because it has variables. The only thing you can do when you have an expression is simplify. And you simplify by adding your like terms. So here 2x and 6x are like terms because they both have x's. 3 and 1 are like terms because they're both constants, so just numbers with no variables. And then 2y doesn't have a like term with it, it's all by itself. It doesn't have any other y's. So we're going to add everything together that has a like term. In other words, you're going to add all of the x's together. So what we're really doing is we're adding 2x plus 6x. We're using the commutative property in our head. And then 2y, you don't really have to have parentheses. This is just a way to think about it. This is what I'm doing in my head. So 2y has nothing to add to it since there's no other y's. And then I can add my 3 and my 1 because those are just numbers. So we end up with 8x. So 2x plus 6x gives us 8x's altogether, plus 2y, plus 3 plus 1 is 4. And this is our final answer. There's nothing we can do from here because we cannot add x's and y's together, and we cannot add constants or the numbers to anything that has a variable. So that's our final answer. Now there's a certain form called standard form in which you're supposed to write your algebraic expressions. The variables should be in alphabetical order, which you can see here. I have my x first, and then I have my y, and the constants should always come last. So you can see that here with my 4. And decreasing exponential order, which was not an issue here. So we'll see some examples of that. So we're going to look at some examples. The first thing you're going to want to do is change all of your subtraction to addition because we're using the commutative property a lot, and you can only switch around the order with addition if it's all addition. You can't have any subtraction when you do that. So the first thing I'm going to do is change this to addition. So this is negative 4x, and anything that follows subtraction should change to the opposite sign when you make this addition. So this is going to be plus a positive 3y plus 2x. Anything that follows subtraction becomes addition, plus negative 6y. Now I can go through and add my like terms. So I can add all of my x's with x's, and I can add all of my y's with y's. And when I do that, I end up with the answer negative 2x plus negative 3y. And that's my final answer because I cannot add x's and y's together. Let's look at one with some exponents. So here we have 7 plus x squared minus 5x squared minus 19. First thing I'm going to do is change all of my subtraction to addition, which means anything following subtraction is going to become addition. So I'm going to make this 7 plus x squared, which there's an understood coefficient of 1 with your variables when you don't see a coefficient. And you can write that in or not, it's up to you. So plus, this is going to become a negative 5x squared plus a negative 19. Now we're going to look for our like terms. Well, we're going to put our x squares together and see how many we have all together. And we're going to put our constants together. And when we do this, we end up with negative 5 plus 1, which is negative 4x squared, plus negative 19 plus 7 is negative 12. And that's our final answer, because we can't add x squares with negative 12. We don't know what the x square is. Let's look at the next one. So before we move on, I want you to understand that what we're doing here is we are adding the coefficients of like terms. And we're keeping the variable and exponent. None of that changes. So you'll see, for example, in this first problem, we had x's and y's. So when we added up our x's, we just saw how many x's we had. That exponent is an understood 1 on our x and an understood 1 on our y. That exponent didn't change any. We were just counting up how many we had. And the next problem, we were seeing how many x squares we had. The exponent 2 didn't change any because we're not changing this to like an x to the third or x to the fourth or anything. We're just seeing how many x squares we had by adding the coefficients, -5 plus 1 to get -4, and keeping the variable with the exponent. So let's try, why don't you go ahead and try the next one and see how you do, and then check back. So you should make sure to change all subtraction to addition so you can clearly see the signs of everything before you add. And then you add your k's together to get -10 k's, plus your 4 and 1 gives you 5, and that's your answer. Okay, try the next one. Again, make sure you're changing subtraction to addition. That's super important. You should end up with -b plus 1 here. Notice that I showed you how you can come in and group all of your like terms if you like doing that better than using color. Whatever way you like to approach this is fine. Also notice that if you have a negative and positive amount of the same number of variables, they will add together to equal 0. So the -8a and positive 8a equaled 0, and the -2b and the positive 2b equaled 0. And you are left with -b plus 1. So we will have examples for the distributive property as part of your problem. And you want to remember to change all your subtraction to addition by keep, change, or anything that follows subtraction becomes addition, okay? Or becomes the opposite sign. So you change it to addition, and whatever follows it becomes the opposite sign. So I'm going to go through and do that first. I'm going to do 2x plus 3 times x plus -6 plus 5x. And you can make this an opposite sign here. Now we're going to, and that's the same thing as putting a -1 there, by the way. You can think of it as an opposite or -1. So now we're going to do our distributive property. So, well, first of all, let me back up. The reason that you do distributive next is you have addition, multiplication, addition, 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 and multiplication, and addition. Okay. Inside the parentheses is where you always start, right, with your order of operations, but you cannot add an x and a -6. They're not like terms. You cannot add an x and a 4. They're not like terms, right? So we come out of the parentheses, and what we're left with is addition, multiplication, addition, addition, and multiplication. So we have to do our multiplication first, which means we're going to do our distributive property. So we're going to distribute everything that's outside of parentheses to within the parentheses. So here we're going to distribute the 3 times the x and the 3 times the -6. Here we're going to distribute this opposite symbol, or this negative. We're going to make everything the opposite sign of whatever it is inside the parentheses. So we end up with 2x here, plus 3 times x is 3x, plus 3 times -6 is -18, plus 5x, plus the opposite of x is -x, the opposite of 4 is -4. Now that we've done our distributive property, all we have left to do is add. So we're going to look for like terms that we can add. So we have a 2x, a 3x, a 5x, and a -x that can be added together. And we have a -18 and a -4 that can be added together. So when we add all this together, we have 2x plus 3x plus 5x plus -x. That's the same as -1x being added together, plus -18 plus -4. So over here, we're going to get 5 plus 5 is 10, minus 1 is 9. So we're going to get 9x plus -18 plus -4 is -22. So we end up with 9x plus -22. And that's our final answer because we can't add x's together with numbers. So we can't add 9x to the -22. Try each of these problems and check back for the correct answer. Once you understand all these problems, you are ready to do some more work and do these on your own.